This tutorial is all about molecular compounds. This is the second type of compound that we've been studying in the grade 10 course. These molecular compounds are different from the ionic compounds that we've been studying. Molecular compounds form between nonmetals. The ionic compounds we looked at were forming between a metal and a nonmetal, or a positive ion and a negative ion. With molecular compounds, you're not going to see a metal in there, and nothing has a charge. Nothing is giving up electrons or gaining electrons. These molecular compounds form through a different type of bond. This bond is called a covalent bond. Covalent is a word that comes from the idea of sharing valence electrons. So if you could take a look at the diagrams down below, we have methane, ammonia, and water. And these are three common molecular compounds. So let's take a look at methane first, and we'll just blow this up a little bit. So methane is CH4. It's a carbon with the 4 hydrogens. We have the central carbon, and it is the central carbon has these 4 hydrogens arranged around it. And if you look at carbon's outer ring, its valence ring, it has these 4 blue dots. And those 4 blue dots represent carbon's 4 valence electrons. Carbon wants to have 8 valence electrons, so it will form covalent bonds with 4 hydrogens. Each hydrogen has 1 valence electron, and that's represented by the red X's. So each hydrogen shares its 1 valence electron with one of the valence electrons from carbon. And this is why carbon has to make 4 covalent bonds. It needs to find 4 electrons that it can share its 4 electrons with. That way it has 8 electrons in its valence shell. Each hydrogen now has 2 in its outer shell, which makes hydrogen full in its valence shell, carbon's full. All these atoms are happy, they're stable, they have a full valence shell. So this is an example of a molecular compound that has formed through covalent bonding. The middle one, ammonia. Ammonia is NH3. So we have this central nitrogen with 3 hydrogens around it. Nitrogen has 5 valence electrons. It wants to make 3 covalent bonds, so it will bond with 3 hydrogens. You end up with 3 shared pairs of electrons. Nitrogen now has 8 electrons in its valence shell. Each hydrogen has 2. All of these atoms are happy and stable. Water, obviously the most common molecular compound out there. It's an oxygen with 2 hydrogens. Oxygen has 6 valence electrons, so it wants to make 2 covalent bonds with one with each of these 2 hydrogens. Everybody's happy, everybody's stable, and this would be a molecular compound. Okay, so hopefully you get the idea of what a molecular compound is. You get an idea of covalent bonding. It's different than ionic bonding. Again, it's between nonmetals only, and in these 3 examples, hydrogen is behaving like a nonmetal. Even though it's way over on the other side of the periodic table, hydrogen can act as both a metal and a nonmetal. In these cases, it is acting like a nonmetal by sharing its 1 valence electron. Okay, so we're going to move on. Here are some really common molecular compounds. I mentioned already about water and methane and ammonia. Now also shown on this little diagram here. Just try and straighten that up. We have some down on the bottom right here. Nitrogen oxide, water, nitrogen dioxide, carbon dioxide. These are all molecular compounds because we don't have a metal. They're nonmetals. They're sharing their electrons. In the top row, you see these 4 molecules: hydrogen, oxygen, nitrogen, chlorine. These are referred to as the diatomic molecules. There are a group of elements on the periodic table that when they're in their elemental form, when they're by themselves, they are always 2 atoms bonded together. So down at the bottom here, I'm showing you the list of diatomic molecules, and you really just need to memorize that when these elements are by themselves, not bonded to another element, they're always going to be in groupings of 2 atoms joined together. And the really common ones are hydrogen, nitrogen, and oxygen, and then the elements of the halogen group. And that's group 17. So fluorine, chlorine, bromine, iodine. These elements always exist as diatomic molecules. This will become important to you later on in the course when you start writing balanced chemical equations. If you saw that you had oxygen in your reaction, you would need to write its formula as O2, not as just O. So try to keep that in mind for, about next week when we start really looking at chemical reactions. Okay, so we're going to move on to how we name molecular compounds. And it's a little bit different than the ionic compounds. So when you're first looking at a formula, you're going to want to make the decision, am I dealing with an ionic compound or am I dealing with a molecular compound? If it's ionic, remember our naming system involves writing the metal first and the nonmetal second and change the ending to "ide." With molecular compounds, it's a little bit like that. We do have 2 parts to the name, but we're not going to have a metal, and we have to indicate with the name how many atoms we have of each of the elements in the compound. So what scientists decided to do, this is an international group of scientists who came up with this naming system. It's called IUPAC, which stands for the International Union of Pure and Applied Chemists. They have developed these naming systems that you're learning right now. This particular naming system, or nomenclature, for molecular compounds involves these Greek prefixes that you can see in the table down below. You should memorize them, but I will probably provide them on any quizzes or tests or the final exam. And most of the time, you're only going to be working up to 5 atoms. So if you can remember mono, di, tri, tetra, and penta, then those are what you're going to need to know for in most cases. So if you have 1 atom of something, the prefix you use is mono. 2 atoms would be di, 3 atoms would be tri, 4 atoms is tetra, and 5 is penta. Some molecular compounds will have large numbers of atoms, and you might be using prefixes for 6, 7, 8, 9, 10 atoms. But grade 10 science, we'll stick to the simpler ones. Here are the rules. There's really only 2 rules for naming molecular compounds. The first one, your molecular compound is going to have 2 parts to it. It's going to have 2 different elements. The first element that's listed, if you only have 1 atom of that first element, you do not put the prefix mono in front of it. But if it's the second element and it has only 1 atom, you would have to use the prefix mono in front of it. You will always use a prefix in front of the second element, no matter how many of those atoms you have. And the second rule is that second element, you have to change the ending to "ide." So oxygen would become oxide. Chlorine would become chloride. So just like we practiced with the ionic compounds, you do the same changing to the ending for the second element for molecular compounds. So we will practice some examples next. Now I want you to get in the habit of always making the decision first, what type of compound do I have here? So for example, if I gave you the compound, oops, sorry, still getting used to this. If I gave you the compound formula CO2, now a lot of you will already know what that's called, but by applying the proper naming system, we're going to write the name of the first element, carbon, and because I only have 1 of those carbons, I'm not going to use a prefix in front of it. I don't need to. But the oxygen part, I have to change to oxide, and I have 2 atoms of it, so I have to show that with my name. And the prefix for 2 is di. So it's dioxide. Now, I know a lot of you knew that that was carbon dioxide, but this is why. This is the naming system. So I'll show you one that you probably don't know. How about N2O5? Now, we want to take a look at this and decide, is this an ionic compound or a molecular compound? We don't have a metal in this. It's two nonmetals. Both nitrogen and oxygen are both nonmetals. So I know that I'm going to use my molecular compound naming system. So I look at the first element, it's nitrogen, and I have 2 atoms of that. So I'm going to need to use a prefix in front of this, and the prefix for 2 is di. So di, nitrogen, and that first element, you don't change its spelling at all, it's just dinitrogen. And then I have 5 oxygens, and the prefix for 5 is penta. Now just a note about oxygen, I'm going to talk about this on the next slide. For oxygen only, because it starts with a vowel, you have to change your prefix a little bit. Instead of penta, I drop the A, and then I write the oxide. So it's pentoxide. And the general rule I always tell students is it should sound smooth. It should roll off your tongue smoothly. If you're struggling to say it, you probably need to drop part of the prefix. So pentaoxide is hard to say. Pentoxide is not hard to say. So N2O5 would be called dinitrogen pentoxide. So as I mentioned on the previous slide, oxygen is a little bit tricky with these molecular compounds. It's got a little bit of an exception to the rules here. Oxygen, if it's in a molecular compound, will always be the second element. You won't see too many formulas that start with oxygen. It's always the second element. And when you put oxygen with mono, tetra, penta, and any other prefix that ends in A, you drop that final vowel in the prefix. So if you have one oxygen, it's not monooxide, it's monoxide. It's tetroxide, pentoxide. It's only the case with oxygen. And with the di and the tri, the prefixes that start with i's, you don't drop the vowel. So it is dioxide, trioxide. And I'm sorry, it's kind of a pain that there are these exceptions for oxygen, but it's the only one that has these exceptions as far as I'm aware. So the last thing I need to show you is how you write a molecular compound formula from a name. So I'm going to give you a name, and these truly are the easiest thing we do in terms of nomenclature, and I'll show you why. So let's say you have the name, oh dear, keep grabbing the text boxes. Okay, let me try this again. Phosphorus, pentachloride. So just like when we were writing names from formulas, we had to decide, do I have an ionic compound or do I have a molecular compound? You must always make that decision first. I know that this is a molecular compound because, for 2 reasons. It doesn't have a metal, so it's 2 nonmetals, and that's what molecular compounds have. Plus, I have this prefix in the name. That should be a red flag in your brain right away. You should see that and say, I know this is a molecular compound because it has a prefix. So to write the formula, all you have to do is decode what this means. All right, I've got 2 parts. Phosphorus. And notice there's no prefix in front of phosphorus. So that means that I have 1 phosphorus. Pentachloride. I have chlorine is my second element, and penta is the prefix for 5. So that tells me that in a molecule of phosphorus pentachloride that I have 5 atoms of chlorine. So the formula is PCl5. And unlike the ionic compounds, we never reduce our subscripts in a formula. So I'll show you one that's kind of like that. So I'll show you one more example here, and it addresses a problem between ionic compounds and molecular compounds. Let's say you have dinitrogen dioxide as the name of your compound. And this is a real compound. Dissect that name. First of all, you need to decide if it's molecular or ionic. Well, we know this is molecular because it doesn't have a metal. It's two nonmetals. And as soon as you see those prefixes, di, right away you should recognize that this is molecular. So we're simply going to translate this into atoms and numbers of atoms. So dinitrogen means I have nitrogen, and the di tells me that I have two of them. Dioxide tells me that I have oxygen, and that I also have two of them. Now, if this were an ionic compound, you would reduce those two subscripts, and they would disappear. That's true for ionic compounds because of how they exist. They are these huge networks of ions, and we really just want to show the proportions or the ratio of the two parts of the ionic compound. With molecular compounds, it's totally different. They exist as these individual molecules, and we need to show how many atoms there are at each of the nonmetal elements. And in this case, it's two nitrogens would be bonded to two oxygens through covalent bonds. So this is correct, and I just don't want you to be confused. As you practice the ionic compounds and you're always reducing the subscripts, do not do that with molecular compounds. So I hope this tutorial has helped you, and good luck with your practice work.